Space is vast, filled with stars, planets, and galaxies. But it's not empty space. Look closer. Between the stars, you'll find cosmic clouds. These are nebulae. Nebulae are immense clouds of gas and dust. They are the birthplaces of stars. This cycle of life and death is essential for the evolution of galaxies. Nebulae are like giant recycling centers. They take the remnants of dead stars. Then they use them to create new generations of stars and planets. Within a nebula, gravity pulls gas and dust together. These clumps grow larger and denser. Eventually, the core becomes hot and dense enough for nuclear fusion to begin. A star is born. When massive stars die, they explode as supernovae. These explosions scatter the star's material back into space, enriching existing nebulae. Nebulae are not just scientifically fascinating, they are also visually stunning. They come in a variety of shapes, sizes, and colors. Some nebulae glow brightly, lit by the light of nearby stars. Others are dark and mysterious, obscuring the light from objects behind them. By studying nebulae, we gain a deeper understanding of the universe. We learn about the life cycle of stars, the formation of planets, and the evolution of galaxies. Nebulae are a reminder that we are part of something much larger than ourselves. Nebulae are not all the same. They come in different varieties. One of the most spectacular types is the emission nebula. These nebulae glow with their own light, like giant fluorescent signs in the cosmos. What makes them shine? It's the intense radiation from hot young stars within them. Different elements emit different colors of light. This is why emission nebulae are often a kaleidoscope of reds, blues, and greens. One of the most famous examples of an emission nebula is the Orion Nebula. Here, we witness star formation in action, as new stars ignite and illuminate the surrounding gas and dust. By studying these nebulae, we can learn about the processes that lead to the birth of stars. Not all nebulae emit their own light. Some, known as reflection nebulae, shine with reflected light. They are like cosmic mirrors, reflecting the light of nearby stars. Unlike emission nebulae, which glow because their gas is energized, reflection nebulae shine because their dust particles scatter starlight. Reflection nebulae often appear blue. The Pleiades star cluster, also known as the Seven Sisters, is a stunning example of a reflection nebula. The cluster of bright blue stars is surrounded by a faint blue haze. Reflection nebulae offer a different kind of beauty. They also provide valuable information about the distribution of dust and the properties of starlight. In the vast expanse of space, there are also dark nebulae. These nebulae are not lit up by stars. Instead, they appear as dark silhouettes against a brighter background. They are clouds of dust so dense that they block the light from stars behind them. Dark nebulae can be enormous, spanning hundreds of light years across. They are often sites of future star formation. One of the most iconic examples of a dark nebula is the Horsehead Nebula in the constellation Orion. Within its dark depths, new stars are being born. They are the reservoirs of raw material from which new stars and planets will eventually form. The Orion Nebula. Visible to the naked eye, it appears as a fuzzy patch in the sword of the constellation Orion. But through a telescope, its true splendor is revealed. A vast, swirling cloud of gas and dust, illuminated by the light of newborn stars. This is a stellar nursery, a place where stars are born. The Orion Nebula is one of the most active star-forming regions in our galaxy. Within its depths, clouds of hydrogen gas collapse under their own gravity, heating up until they ignite as new stars. The Orion Nebula is relatively close to Earth, about 1,300 light-years away. By observing the Orion Nebula, we gain insights into the processes that gave birth to our own sun and solar system. In the constellation Serpens, some 7,000 light-years away, lies the Eagle Nebula. This nebula is home to one of the most iconic images in astronomy, the Pillars of Creation. These towering columns of gas and dust, captured by the Hubble Space Telescope, are a testament to the power of star formation. Within these pillars, new stars are being born. The intense radiation from these newborn stars sculpts the surrounding gas and dust, creating the pillars' dramatic shapes. The pillars are constantly being eroded by the radiation of the stars they are forming. Eventually, they will be completely dissipated, leaving behind a cluster of young stars. The Pillars of Creation are a snapshot in time, a glimpse of the ongoing process of star formation. Not all nebulae are birthplaces of stars. Some are the remnants of stellar death. The Crab Nebula, located in the constellation Taurus, is a prime example. This chaotic, expanding cloud of gas is the aftermath of a supernova explosion observed by Chinese astronomers in the year 1054 AD. The Crab Nebula is a supernova remnant, a cloud of debris ejected into space when a massive star explodes at the end of its life. At the heart of the Crab Nebula lies a rapidly rotating neutron star, a pulsar. The Crab Nebula is one of the most studied objects in the night sky, providing insights into the processes of stellar death and the physics of extreme environments. The Crab Nebula is a cosmic time capsule, preserving the remnants of a cataclysmic event that occurred nearly 1,000 years ago. In the constellation Aquarius, some 650 light-years away, lies a nebula that seems to stare back at us from the depths of space, the Helix Nebula. This planetary nebula, so called because of its resemblance to a planet when viewed through small telescopes, is the remnant of a star much like our Sun. When a Sun-like star runs out of fuel, it sheds its outer layers into space, forming a planetary nebula. The core of the star collapses to form a white dwarf, which illuminates the surrounding nebula. The Helix Nebula's distinctive eye-like structure is a result of the way the gas was ejected from the dying star. The outer layers of the star were blown off first, forming the outer ring of the nebula. The Helix Nebula is a poignant reminder of our own mortality. It shows us the fate that awaits our own star and solar system. Stellar Nurseries, where stars take their first breath. Nebulae are not merely beautiful displays of cosmic dust and gas. They are, in a sense, the maternity wards of the universe. These vast clouds, often light-years across, serve as the birthplace of stars. Within their swirling depths, the ingredients for stars, hydrogen, helium, and a smattering of heavier elements mix and mingle, awaiting the trigger for their transformation. Imagine these nebulae as cosmic kitchens. The gas and dust are the ingredients, gravity is the chef, and stars are the delicious dishes that emerge after eons of cosmic cooking. It's within these cold, dark clouds that gravity begins its work, pulling together clumps of gas and dust into denser and denser regions. The nebula becomes a crucible for creation, a place where the fundamental forces of the universe conspire to ignite the fires of new stars. Gravity's dance, the collapse of a nebula. Gravity, that invisible force that holds us to the Earth, plays a starring role in the birth of stars. Within a nebula, gravity acts as a sculptor, molding and shaping the raw materials of gas and dust into the building blocks of stars. It's a delicate dance, a balance between the outward push of gas pressure and the inward pull of gravity. Imagine a giant game of cosmic tug-of-war. On one side is the force of gravity, relentlessly trying to pull everything together. On the other side is the internal pressure of the gas cloud, resisting the inward collapse. As gravity gradually gains the upper hand, the nebula begins to fragment, breaking apart into smaller, denser clumps. These clumps, called protostars, are the seeds of future stars. From protostar to star. The ignition of nuclear fusion. The journey from a protostar to a fully fledged star is a remarkable one. At the heart of this transformation lies a process known as nuclear fusion, the very engine that powers the stars. As a protostar continues to collapse under its own gravity, the pressure and temperature at its core reach unimaginable levels. Millions of degrees Celsius, a heat so intense that atoms themselves are ripped apart, their nuclei bare and exposed. Hydrogen nuclei are forced together with such incredible force that they fuse, creating helium and releasing an enormous amount of energy. This energy radiates outward from the core, counteracting the relentless inward pull of gravity. A star is born. Section 4. Stellar Recycling, the Circle of Star Birth and Death. The story of stars and nebulae is not a one-way street, it's a cycle, a continuous process of birth, life, death, and rebirth. Nebulae provide the raw materials for stars, and stars in turn enrich nebulae with the elements they forge during their lifetimes and explosive deaths. When a star reaches the end of its life, it expels its outer layers back into space, enriching the interstellar medium with these newly forged elements. This expelled material often forms beautiful and intricate nebulae, seeding the next generation of stars. Massive stars end their lives in spectacular explosions called supernovae. These cataclysmic events scatter the star's enriched material far and wide, seeding the interstellar medium with even heavier elements. This ongoing cycle of stellar evolution ensures that the universe is constantly evolving, with each generation of stars enriching the cosmos with the building blocks of planets, life, and everything we see around us. Section 1. The Cosmic Dance of Star Formation. Nebulae are more than just passive clouds of gas and dust. They are active participants in the grand cosmic dance of star formation. Gravity orchestrates the intricate ballet of stellar birth, pulling together the raw materials of stars. Imagine a nebula as a giant cosmic ballroom filled with swirling couples of gas and dust. Gravity acts as the master of ceremonies, guiding these couples into ever tighter spins. As they draw closer together, their combined gravitational pull strengthens. This cosmic dance is not without its drama. As the gas and dust are drawn inward, they heat up, releasing energy. The nebula begins to glow, illuminating its surroundings with a soft, ethereal light. The process of star formation is a delicate balancing act. The inward pull of gravity must overcome the outward pressure of the heated gas. It's a battle between two fundamental forces of the universe, lasting millions of years. Section 2. Triggering stellar birth, shockwaves, and stellar winds. While gravity plays a leading role in star formation, it often needs a little help from its cosmic companions, shockwaves and stellar winds. These energetic phenomena can act as triggers, compressing gas and dust within nebulae and setting the stage for the formation of new stars. Imagine a shockwave generated by a nearby supernova explosion, ripping through a nebula like a cosmic tsunami. As this wave of energy slams into the surrounding gas and dust, it creates regions of high density, squeezing the material together and accelerating the process of gravitational collapse. Stellar winds, streams of charged particles constantly flowing from the surfaces of stars, can also play a role in triggering star formation. These winds, like cosmic breezes, can push and sculpt the surrounding gas and dust, creating regions of higher density within nebulae. These external triggers, combined with the relentless pull of gravity, can tip the balance in favor of star formation. A nebula that was once a tranquil cloud of gas and dust can be transformed into a bustling stellar nursery, bursting with the light of newborn stars. Section 3. The Role of Supernovae, Stellar Death and Cosmic Rebirth. While supernovae are often associated with destruction, they are also essential for cosmic rebirth. These cataclysmic events, marking the explosive deaths of massive stars, seed the interstellar medium with the heavy elements essential for the formation of planets and even life itself. Imagine a supernova, the brilliant death throes of a star many times more massive than our Sun. For a brief moment, it outshines its entire galaxy, releasing as much energy as our Sun will radiate over its entire lifetime. But from this cosmic maelstrom comes new creation. As the shockwave from a supernova propagates through a nebula, it not only triggers the formation of new stars, but it also disperses the heavy elements forged in the heart of the dying star. These elements, including carbon, oxygen, and iron, are the building blocks of planets, and without them, life as we know it would not exist. Supernovae are the ultimate cosmic alchemists, transforming the simplest element, hydrogen, into a rich tapestry of heavier elements. In death, they breathe life into the universe, enriching Nebula with the ingredients for future generations of stars, planets, and perhaps even life. Section 4. From Nebulae to Planetary Systems, the building blocks of worlds. Nebulae are the birthplaces of stars and planetary systems. Gas and dust form stars, planets, moons, and comets. A young star ignites, surrounded by a swirling disk. This disk is a cosmic whirlpool of potential planets. Dust grains collide, forming planetesimals. These are the building blocks of planets. Nebulae are cosmic nurseries, transforming raw materials into planets. When we look at a nebula, we're not just seeing a beautiful cloud of gas and dust. We are looking back in time. Light travels at a finite speed. The light we see from distant nebulae has taken thousands, even millions of years to reach us. Imagine a letter traveling across the vastness of space. It carries a message from a distant realm, a message written in the language of light and color. The farther away the sender, the longer the message takes to arrive. The light from these nebulae started its journey long before humans walked the Earth. When we study nebulae, we are uncovering secrets from the early universe. We are witnessing the processes that led to the formation of stars and galaxies, the very building blocks of our cosmic neighborhood. Nebulae are like cosmic time capsules. They preserve the history of the universe, allowing us to piece together the story of how we got here. Nebulae are not just distant and beautiful objects, they are intimately connected to our own existence. The elements that make up our bodies, the air we breathe, the ground we walk on, all were once forged in the hearts of stars and scattered throughout the universe by supernovae. Think about that for a moment. The iron in your blood, the calcium in your bones, the oxygen that fills your lungs, all were created in the nuclear furnaces of stars long ago. We are literally made of star stuff. The atoms that make up our bodies were once part of giant swirling clouds of gas and dust. They were born in the fiery hearts of stars, and they were scattered into the cosmos when those stars died. Nebulae are not just cosmic art galleries, they are the factories of the universe, churning out the elements that make life possible. Nebulae remind us of the vastness and wonder of the universe we live in. They inspire awe and humility, urging us to look beyond ourselves and contemplate our place in the grand scheme of things. They are a testament to the power of nature, to the beauty and elegance of the laws that govern the cosmos. Take a moment to look up at the night sky. On a clear night, far from city lights, you might catch a glimpse of a faint, fuzzy patch of light. That's a nebula. A vast cloud of gas and dust, light years across, where stars are being born and dying. It's a humbling thought to realize that we are part of something so much larger than ourselves. But it's also an inspiring one. The universe is full of wonders, waiting to be discovered. Nebulae are just one of the many treasures that await those who dare to look up and explore. The study of nebulae is not just about understanding the universe around us, it's also about understanding ourselves. By exploring the cosmos, we gain a deeper appreciation for our own planet and the preciousness of life. We realize that we are all connected, not just to each other, but to every star, every planet, every atom in the universe. We are all children of the cosmos, born from the same stardust that forms the nebulae. We are part of an interconnected web of life and energy that spans the vastness of space and time. Let us never forget our cosmic connection, our shared heritage as citizens of the universe. The next time you look up at the night sky and see a nebula, remember that you're not just looking at a beautiful object. You are looking at the birthplace of stars, the remnants of stellar death, and the building blocks of life itself. You are looking at a reflection of our own cosmic origins.